It's something to do though.
Pardon?
I said it's something to do.
Some process some cattle. Keeps you on your toes.
I think I'd rather do calculus homework.
Okay, does everybody have their assignment there? I'm gonna look at the assignment. Okay, so first question in the assignment. There was a couple of things that you had to read into it. All right. First one, it says an electric iron has a mass of 1.5 kg. So 1,500 grams. The heating element is a 2-meter length. Tungsten wire. So the rho constant for tungsten is that it has a cross-sectional area of 0.004105, and you get that from the chart at the back of the book. Okay. It says what time is required, so I'm looking for my time. It's required for a zinc plated iron to be heated. So that's also information that we have to take into account. So the temperature change was 133 degrees Celsius when connected across for zinc. So most of you didn't do this part. So I need the C value for zinc, which was I think most of you use water for that. But I didn't look at it real close yet. So I've got MC delta T, all right? And that's the information that I need. So first thing I'm going to do is find my resistance. So I'm going to find my resistance first by taking 120 volts, or sorry, I'm going to use my information for tungsten. So I've got my rho times my L over my A, and I get it to equal 0.02728 ohms. Okay? So the output then, or the input, sorry, so the Q equals MC delta T here. I have 1,500 grams times 0.0922 times 133 degrees Celsius, and that worked out to 18,393.9 calories. Okay, so the air that most people made was right here, not using zinc, because that's what was heated. It's a zinc plated element. Okay, iron element. So that was that. Go ahead.
It says iron, so how do you know, like in the other questions it's iron?
Yeah, but okay, so in the other questions, Mary, it would say, okay, you're heating water, you're heating alcohol. But in this, you're heating a zinc plated iron.
So you're heating the zinc?
So that, okay, so the element itself is zinc. It's got zinc on top of it. So we're just trying to find out how much heat the zinc is. how long it takes to heat the zinc 133 degrees Celsius. Okay? All right? Like I said, these questions were a little more than what we were used to, so that's okay. All right? So now the time, I got to go QJ over I squared R. My Q is 18,393.9. My J is 4.19. My I haven't calculated I yet. My I take my 120 volts and I divide it by 0.728 and I get 439.821 amps. Okay, so that's 439.821 squared times my resistance of 0.2728. And the time for this works out to 1.4605 seconds. So, those of you that have 1.702, because I know you guys were comparing them, you used water instead of zinc there. Okay, nowhere in the question does it say anything about water, right?
I use iron, not water.
I know, zinc plated iron. Oh, I see what you're saying. Sorry, I understand what you're saying. You said iron instead of zinc, right?
Yeah.
Yeah, okay. Okay. All right. Okay, so question 2. Almost identical question. The only thing they didn't give us is they didn't give us all of the tungsten wire stuff. They're now talking about an element and raising the temperature of alcohol. Okay, so first thing they give us 10 amps. So I'm just going to make a list of all the things that were given to us. So I've got 10 amps, 110 volts. I know to calculate my resistance. Then I'm given a time, 502 seconds. My mass, my first mass is 600 grams. My C for alcohol, temperature change is 54.37 degrees Celsius. Now, this is new. So if you didn't watch that video yesterday, then you wouldn't know what you needed to do here. There is an excess amount of heat that's required to change the state. So what that means is this. If you're melting an ice cube, in order to melt the ice cube from ice to water, and change the state of it, you need an excess amount of heat, not just the amount of heat that's doing it to melt it, but you need an excess amount of heat. That's called the latent heat of fusion. When you go from a liquid to a gas, you have the latent heat of vaporization. So there is 60 grams of alcohol being boiled off. So that's 60 grams. And the latent heat of vaporization is found on the same chart as the specific heat constants. And it is 204 calories per gram. So for every 1 gram I'm boiling off, changing from a liquid to a gas, I need an extra 204 calories of heat in order to change that state. All right. So now, do all my work up here. So I've got I squared RT over J. So 10 squared, 11, 502 over 4.19. So the output of my element is 131,789.976 calories. Okay. The Q, so is MC delta T plus MLV. So that is 600 times 0.581. Oops. Six hundred times 0.581 times 54.37. Add 60 times 204. So the amount of heat required would be 31,193.382 calories. And to find the efficiency then, I take the amount of heat that's required to raise that temperature and change and boil off that alcohol, divided by the amount of output that's being put in by the element, and my percent efficiency in this question, 23.669%. Okay, so the one add on or add in or whatever you want to call it is right here. And again, we talked about that yesterday when I did the question, I think it was question 6 on your assignment sheet. Yeah. So if you're doing your assignment sheet on time like you're supposed to, then you would have seen that on question 6. Okay. And finally, number 3, given 115 volts, power is 240 watts. Take 240 volts, divided by, 240 watts divided by 115 volts, gives me 2.087. Now that's amperes, which when we first started all of this, we learned was coulombs per second. All right. Now we need to calculate the number of electrons that flow. So what we do is we take 14 hours, we multiply it, change that to seconds. That cancels, seconds cancel. And then I have 6.25 times 10 to the 18. Electrons in 1 coulomb. That cancels. That leaves me with 6.574 times 10 to the 23rd electrons. Okay.
Do you think you could go back to question 2 so I could just copy it down quick?
You bet. You bet. Okay. All right, so we should be done that first assignment sheet. If you're not, you're a little bit behind right now.
Where do you want us to be done till, like, where in the worksheets do you want us to be finished to till, like, tomorrow?
You should be done the first side of the second worksheet.
The first side of the second worksheet, okay.
That one's a little bit longer on that first side. There's about 6 or 7 questions on it.
Okay.
All right, you good, Mary?
Yeah.
Okay. Are there any other questions from the worksheet that you want to go through before you have to sign off here today?
Can you do question 12?
Question 12?
In the book.
Yeah.
Like this is.
Yeah. Just let me grab the textbook, Justin. There it is. It's hiding. Sure. Okay, so a percolator with a heating coil of 20 ohms resistance. Across 120 volt line. Time is 1 second. And I need Q. Okay, so when I'm dealing with heat with Q, Q is equal to I squared. I squared RT over J. So I have R, I have T, I have J. J is a constant. I didn't write that down. Where is it? Forgotten what my unit is. It's joules per calorie, isn't it? 1.19. Yeah. Okay. So this is what I have. So the first thing I want to do, Justin, is find out what I is. So I go 120 divided by 20, which gives me 6 amps. The whole thing with this question that throws you a little bit is that it's this 1 second part. Because it per second, you treat the time as 1 second. So now I go equals 6 squared times 20 times 1 divided by 4.19. So that is, my calculator is over there. So that's 36 times 20 divided by 4.19. So I get 171.838 calories, okay? And then it says it is connected, it contains 500 grams of water at 22.5 degrees Celsius. How much time is required to heat the water to boiling, assuming no loss of heat? Okay, so oh, I lost it. There we go. My Q has to change for this one. Now I've got to find it for water. So my water, 500 times 1 is my specific heat constant, that's C, and 22.5 to 100 is 80 or 77.5 degrees Celsius. So I calculate my Q. So I use 38,750 calories times 4.19 over 6 squared times 20. I get 225.5 seconds.
Thank you.
You're welcome. Did you have any other questions, Justin?
No.
Okay. Anybody else have questions this morning? I know a couple of you got to go to your calculus meeting.
Yeah, I better go, but thank you.
Okay, make sure that you're completed chapter 7 in pre-calculus and that first side of that sheet on physics. Okay?
What time do you want that assignment at?
Today,
Okay.
please.
Okay, bye.
Okay, see you guys. The rest of you doing okay? Girls, I only have 2 of you left now.
Yeah.
Rory, you good?
Yeah, I'm alright.
Okay. Okay, that's good for today. If you don't have any other questions, I'll get back to you tomorrow. Okay?
Alright.
Okay, talk to you later. Bye.
Bye.